Just don't make much either. Once my husband's working as an engineer, I don't have to make a lot of money. I want to do something for the rest of my career that I enjoy.
Okay, so now we look at white blood cells. Oh, by the way, you know that red blood cells are called erythrocytes. Now this one, you call them leukocytes.
I had a question. There's no DNA in red blood
Red
cells,
blood cells.
but you can draw blood and get DNA from blood. Where does the
From
DNA
the
come from in the blood?
It's from the bone marrow. So that's a very good question. The mature, I guess I should correct myself. Thank you. The mature red blood cell has no DNA. But the one from the stem cell, as it matures, look at this. You heard of reticulocytes? These are baby red blood cells. They still have DNA.
That's where they get the DNA from. Okay.
Because the red blood cells have to make the hemoglobin first by protein synthesis. Remember, protein synthesis involves transcription, translation. So they still have DNA there. But once they have made all the hemoglobin, they get rid of that, and they only have
They dump what they
hemoglobin.
don't need
They,
so they
they're-
can carry more.
That's right. Okay? They're just very selfless cells. Now we go look at our leukocytes. Okay? And we know what, look at now, they have nucleus, they are referred to as complete cells. These are the only complete cells in the blood, if you think about it. Remember, your red blood cells, no nucleus, it's incomplete. And then the platelets, tiny little plates, incomplete. These are the only complete cells. I remember asking in the past, I don't know again about that, asking something about why cancer, if you think about it, cancer of the blood always involves white blood cells in general, not the red blood cells or the platelets. This explains it, right? Because these are the complete cells. Remember, cancer involves increased division, cell division. So how can you have cancer of red blood cell? They don't divide. How can you have cancer of platelets? They're fragments. This is the one. Okay?
They always have
Nucleus. Okay? So here, so we know that in general, what do? They fight infection. And how are they able to do that? They have that property called diapedesis. They're able to move out of my, in fact, they shouldn't be staying in here. I want to go back to this slide just very quickly. Look at this. If you look at this, look at you have millions of red blood cells in your blood, in the blood. You have 250 to 400,000 platelets in the blood. But look at how many white blood cells. This is normal. Less than 10,000 white blood cells in the blood. Why? They're not there. Where do you usually have a boo-boo? In the blood immediately? No, it's outside. So, because of their job is to protect you from infection. They are deployed. So they have that capacity of moving. The movement, the amoeboid movement of white blood cells is referred to as diapedesis.
Who comes up with these names?
And where do they go? They go to an area of infection. So the infected part of the body secretes chemicals. And these chemicals are what attracts these white blood cells. So they move towards the infected area, attracted to the chemicals that the affected cells release. So that movement is referred to as chemotaxis. like a taxi. They ride the taxi going to the area where there's a chemical being released. Chemotaxis. These words are going to be helpful. If you remember, they will help you in answering your blood worksheet. That's your next worksheet that you're going to give to me. Okay? So that's why you don't see them inside the blood. You only see a little bit of them, up to 10,000, but that's not because they don't help. They're outside or they're deployed. They're your border patrol. Okay? Chemotaxis.
So which is why they know if 16, 18,000 of them show up in your blood that you've got an infection somewhere.
That's very good. Very good. Okay? So, I want you to be able to identify the different types of white blood cells. Okay? So, this one, what's this? This is? Yes. What's this speck?
Platelet.
Yes. Over here, plasma. Now it's very easy to identify the different types of white blood cells. By the way, look at this. They have a nucleus. And the key word is a nucleus, just one. Even though it looks like this one has 3, has 2, they all have just one nucleus. The banding of the nucleus. So it's like a rubber band that ligates it or constricts it at certain points. The banding pattern of the nucleus helps in identifying what white blood cell this is. So this is a lymphocyte. The lymphocyte is almost as small as a red blood cell, and it has like just a halo of, this one is nicer, a halo of cytoplasm around it, you see? So the nucleus almost occupies the whole space. That's how I identify a lymphocyte, okay? I identify a neutrophil. Neutrophil is the one that is a polysegmented. So many bands. Very obvious, neutrophil. Monocyte, kidney shape or horseshoe shape, big. Very easy. And then eosinophil has, the key to eosinophil, it looks like a telephone, they say, the nucleus or the barbell. And plus the red pigments. Eosin, red. The red pigments. And then this is how basophil looks like. Basophils and eosinophils actually have the same bilobed nucleus. It's called bilobe. But the pigments here are basic in appearance compared to this one, red. How are we going to study our white blood cells? You're going to study in terms of what type of disease are you fighting if this is high. So if the neutrophil count is high, you're going to say neutrophilia. If it's low, you say neutropenia. The same for eosinophilia, eosinopenia, okay? So if your neutrophil count is high, you're going to write nu for new. You're fighting a new infection or acute. You ever get a diagnosis of acute bronchitis or acute whatever? That's because when they did your WBC differential count, WBC diff, this is the one that's high. So I remember in my first lecture test, I had clinical scenario and I give the WBC diff count and you give me the diagnosis or you give me the plan of action. Are you going to give antibiotics to this one or are you just going to give whatever, okay?
How do you know it's high or low?
I'm going to give you the standard count. So of course there's
Okay.
standards, and then if it's high, then you know. If this one were a bacteria in general, this and this are generally bacteria.
Are you going to give us like the numbers
Yes. So if this and this does, in general, this tells you you're fighting a bacterial infection. If this is the one is high, you're going to write you have a chronic infection now. So chronic bacterial pneumonia. So it's been going on for a while, an old infection. So for neutrophil, right, acute. This one chronic or old infection. This one, eosinophils, they are high when you're fighting an allergic infection or parasites. Like I heard about the tapeworm diet that models used to do so that they will not gain weight, the tapeworm will eat the food. So I'm sure they have eosinophilia. So either allergy or parasites. Okay? The basophils are always present in any kind of infection. Every time you have inflammation, you know your basophil count is high because they have two types of granules here. One is histamine. What is histamine? What is an antihistamine?
It's an allergy.
For to control the allergy. And when you have allergy, there's swelling, there's inflammation, right? So histamine promotes swelling. And then the other granule that it contains is heparin. What is heparin?
It's a clotting agent.
That's very good. It controls clotting, right? So heparin thins the blood. So there's an advantage to this one, the swelling and the clotting. So it swells, allows all the white blood cells to get there and also to contain the infection. The heparin makes sure they don't clot. See, they're crowding themselves with the cells. There's a possibility. You don't want to clot. You just want them to be there and do their job, contain the infection. Okay? Next, lymphocytes. If your lymphocytes are high, in general, your problem is viral or fungal. Virus or fungus is what you're fighting. Okay? So that's how I want you to study your white blood cells. So how do they do their job? How do they kill? It's called an oxidative burst. For one thing, they are phagocytic. So they phagocytose the bacteria, goes in there, and then they secrete or they make free radicals. So the reaction with the bacteria creates superoxide radicals, which kills the bacteria, but it also kills them as a result. So it's like a suicide. So what is produced is what you call pus. So when you have pus, you have dead bacteria. You also have the white blood cells that died. But that's good. They were able to contain the infection. Okay? So a few terms I want you to know. Leukocytosis. You're going to use these terms in your blood worksheets. Leukopenia, leukemia. Leukocytosis, increased white blood cell count. Leukopenia, decreased white blood cell count. Leukemia is cancer, right? Why is it, and I remember asking this even in the final exam, why is it that people with leukemia, if you think about it, they have increased white blood cell count, and yet they are still prone to infection? Leukemia patients are weak. They're immunocompromised. Why do you think? it's because it's cancer, so it's not normal, right? The white blood cells, even though they have a very high white blood cell count, they are abnormal white blood cells. So they're not useful to fight infection. They're cancer. Okay?
How do you get cancer of the blood?
Huh?
How do you
How?
get like cancer?
How do you
of the
get
blood?
cancer of the
Does
blood?
that mean their platelets aren't functioning because the platelets are responsible for your immunity?
No, not the platelets. It's the white blood cells that's responsible for it. Platelets are for clotting. They're you get cancer many ways. You can be exposed to free radicals. That's the most common. Um, any kind of nuclear, chemical, whatever. So that's how you can get cancer of the blood. The what do you call it? Biological warfare. Right? The Chernobyl incident, remember that? So after decades, several decades, people have been showing up with leukemia. The Agent Orange in Vietnam, those people, or Vietnam War,
Yeah.
right? The soldiers, the veterans, there's a lot of them with leukemia. Then when they're trying to apply for veterans help, they deny. They say there is, they want, I just feel so bad for them. Anyway, do you have any questions so far? So that's how I want you to study your white blood cells, okay? Just WBC diff count, because there will be clinical cases, and then I want you to tell me, what do you think you want to do? Are you going to apply, you give antibiotics, what are you going to do with this one, what are you going to do with this one? And I'm going to make sure I give you the normal count. So there's normal, and then you just figure out which one is increased, that's all. Okay? And you need to remember, so your neutrophil and monocytes bacteria, eosinophil parasites or allergy, same with basophils. The lymphocytes fungus or virus. Okay?
So which ones would you give
Antibiotics?
antibiotics to? There we
Either
go.
viral or the bacterial.
You don't give antibiotics in virus, the bacteria.
The bacteria.
For viral, antiviral medication.
Okay.
Antibiotics are for bacteria. Next, we have our platelets. Our tiny little plates. So, these are called thrombocytes. Look at your hormone, thrombopoietin. Don't forget those hormones, okay? You understand now, right? How they get called. So, when we think platelet, we always think clot. So that's the function of platelets, is for clotting or hemostasis. And actually there are 3 phases to hemostasis. Okay? Vascular, platelet, coagulation. You don't need to, oh well, I think this is going to be asked in your worksheet. Okay? So, but this is very easy to understand how we clot. Look at this picture over here. When we have a cut, that means when there's blood, that means a blood vessel has been severed. And when the blood vessel was severed, the wall of blood vessels have smooth muscle. So when we cut, you irritate the smooth muscle. How the smooth muscle react? They contract, right? So that's the first thing that immediately happens when we have a boo-boo. It's called spasm. They go into spasm. So when they contract like that, don't you think that that will be helpful? Because it promotes, it slows down the blood there, and it makes contact between the platelets and the injured part. Which is the second phase, the platelet plug. Again, picture in your head, I had a boo-boo, thus the injured vessel responds by contracting. That's the vascular spasm. When it contracts, it decreases the diameter of the blood vessel, so it creates a traffic jam. What results is the platelets get called. How do the platelets get called? The platelets, look at this shape, look at that shape, okay? Normally, look at the normal shape of platelets, very pretty, round. But when it encounters a bumpiness, like when your foot is stuck and I get tripped, it gets tripped and it starts, look at the next one, it starts changing shape. Look, it changed shape. It promotes those spikiness. So this is the example of, you remember, positive feedback mechanism? So only one platelet needs to be tripped. And this one platelet that was tripped, it will call on the rest, the other platelets. They will trip the rest until you form a plug. But this is something very scary because platelets get activated when they encounter a roughness. The roughness happens when you have a blood clot, a boo-boo, yes, but also when you have any kind of bumpiness from cholesterol plaque. That's why we worry about cholesterol plaque, right? You say, oh my goodness, you may have stroke. You may have, you have roughness that you have there already, scattered roughness that is potential for platelets to be tripped. All you need is for the platelet to be tripped. There's one more way to trip those platelets. Cigarette smoke. So there are chemicals in the cigarette smoke. We know that when we inhale the chemicals, what they do is they activate the platelets. That's the thing. That's why cigarette smoke carries the risk of stroke, right? Or forming plaques because they trip the platelets. And the secondhand smoke, and that's where the Surgeon General has that warning there. Secondhand smoke, you think, what do you think? Do you agree with me? Children, the Surgeon General came out with this statement. Children up to 5 years old are 7 times more sensitive to cigarette smoke damage than adults. When they inhale it, because their cells are more sensitive, right? More active. So that's why when Baba smokes his cigars, I tell him to smoke outside. Even if it's freezing, you stay outside. I don't want Lily to smell. Because, look at, it will activate the platelet. Again, platelets don't know any better, right? They just have a job. So it's good if you really have an actual boo-boo, but they can also be activated by cigarette smoke or any kind of bumpiness, cholesterol. That's why we always want to be physically active. We don't want that cholesterol to be forming a plaque anywhere. You understand? Okay? So that's the second phase. The last phase of blood clotting, and this is the most effective phase, is called clotting or coagulation. Coagulation. So what was the first spasm? Vascular spasm, and then platelet, plug, and then the last is coagulate. So look at this picture over here. What I want you to remember is this. In our blood all the time, we have what you call clotting factors. I'm not going to require you to remember all these factors, too much for you. But we have these factors all the time in our blood. They are just in inactive form. Okay? So they're there in inactive form. When they get activated, look at, when they get activated, I'm sure you heard of factor 7, these are your clotting factors. When they get activated, it's a cascade. What is the end result? Look at prothrombinase. The prothrombin becomes thrombin. Are you familiar with thrombosis? Thrombus, this is it. And this serves as an enzyme to convert fibrinogen, remember your third protein, and it becomes fibrin. This is the clot. But I want you to look at this slide. Look at, there is what you call extrinsic pathway where there's an actual damage when I had a boo-boo. So this is, remember what I told you, that injured cells secrete chemicals, right? There, the tissue factor. So this is what the injured, how the injured cells talk. So they secrete this and triggers the cascade of clotting. That's good. I had an actual damage. But if you look at this other side, intrinsic pathway. This, I didn't have an actual boo-boo. You see? This is the one that can be triggered if I just have cholesterol plaque. It's scary. Right? So that's why I want to always keep walking, keep walking. Don't let that clot to be settling there. Because why? They don't know any better. All they know is if there's a trip somewhere, they activate this one. And then you end up with a clot. Do you understand this slide? Okay? So the last part of this chapter talks about blood typing. Are you familiar with blood typing? Okay. Okay. And I'm going to get the poster of blood typing.
Yes.
So here are posters of the blood cells. And here is our blood typing. Okay? So what you need to know, are you familiar with antigen, antibody? Right? So antibodies are the chemicals or the proteins that fight infection. So in my body, I have antibodies that protect me from infection, right? And what is an antigen? An antigen is anything foreign, right? Anything that does not belong to me is considered an antigen, right? Yes? Okay. So if I transfuse my blood to you, my blood becomes an antigen. Yes? What
Yeah.
you think? And that's how we identify our blood type. I identify my blood type depending on the antigen that is present on my red blood cells. Do you follow? Where do you think I will have the antibodies? The antibodies will always be in the plasma, right? Remember, blood is made up of plasma and my cells. Do you follow? Remember? So where will you find your antibodies? In the plasma. So this is in the plasma. And again, when I transfuse my blood to you, my blood is considered an antigen by your body, right? So this is how I identify my blood. If I have the A antigen, I am type A. Yes? So if I am type A, I will have antibodies against B in my plasma. Right? So type A people cannot receive type B blood because they have anti-B antibodies. If I have B antigen, I am type B. I will have anti-A in my plasma. I cannot receive type A. If I am type AB, I will have both A and B antigens, right? Will I have antibodies against my own? No. So That's why the AB is, you remember it used to be referred to as the universal recipient. You have a crossword in your blood worksheet. Universal, the type AB, and people always wonder what's the correct universal receiver. I think that's what they're using for the crossword instead of recipient, receiver. And then people with type O have no antigen, so that means they will have antibodies against both A and B. They cannot receive type A or type B, but they can donate, right? Because if this is your blood type and you donate, you're not going to trigger a reaction to the recipient. You don't have any antigens there. You see,
Is that why they want type O?
for donation.
Does it matter if you're positive or negative?
Yes.
That yes, but I usually don't talk about the positive negative, only because, and the main reason is because it usually is very important when it during pregnancy, number one, and number two, it's very easily corrected now. But that Rh positive, Rh negative refers to the Rh factor. That's another antigen. So there are actually three major antigens, the A, the B, and the Rh. But this Rh only comes into play with pregnant people. 85%, 80 to 85% of the whole population in the whole world are Rh positive. So there's only that few who's Rh negative. And you would think that if you're Rh negative, you're going to have antibodies against Rh. That's not the case. Okay? So this only becomes important if you're carrying an Rh positive baby. And then when you give birth, there may be a mixing. When there's the placenta is delivered, there'll be a mixing of the baby and the mommy blood. That's when the mother gets sensitized and she starts making antibodies against Rh. So the threat is not with this baby, but the next baby.
Will her blood actually change if
Not change, but, and they don't mix. Just that the red blood, the blood of the baby can lyse, erythroblastosis fetalis. So the baby blood will lyse, so the baby starts hemorrhaging. But now it's very
They
easy.
give you a shot. I had to have a shot.
That's
Rogam.
it, right? It's
Negative.
called Rogam.
Yeah.
Very easy.
They think, history thinks that that's what happened with Henry VIII, with
Oh.
Anne Boleyn. She had the first baby and was Rh negative.
Oh.
And so every pregnancy she had after that, she miscarried because they
Oh
think
my
that she was
goodness.
Rh negative.
But now, if only they knew, it's just a shot, a simple shot. What that shot does is it covers or shields the mother from the Rh, so that you will carry this baby to term. When you deliver, no problem. Your shield, the Rogam.
Do they do
shields
it
you
after every pregnancy?
every pregnancy. So for your test, I just only do the AB blood typing. That's going to be included in your lecture test. So how do you find out your blood type? This is what you're going to do your activity, okay? So you're given a sample. So initially, the blood is all like this. Right? Imagine all of these plates like this, all of this, no clumping like that, okay? So look at, this is the blood sample. So imagine, bring this up here. And what I did, I squirted, or I dropped anti-A antibody. This is the antibody I dropped here. If this blood has the A antigen, it will clump. So I know that this patient is type A. Let me look at, I dropped anti-B, it didn't clump. So the patient is just type A. This B is the Rh. We don't include that in our test. Do you understand how you get your blood type?
No.
Again, imagine, so just don't look at this first part right here, just look at this one. It looks like this in the beginning. If I drop anti-A antibody here and it clumps, it started clumping like this. What does that mean? It means that this blood has the A antigen on its cell membrane, right? And it clumped. Then I'm going to drop anti-B antibody. It didn't clump. There's no B antigen. So your blood type is type A. Okay? Clumping is called agglutination. This is different from coagulation, right? Coagulation refers to clotting. Agglutination refers to clumping. They start clumping together. Because the antibody clumps the red blood cells together, clumping. This is the danger. This is why we don't want to transfuse mismatched blood. If it's mismatched, they will clump and cause clotting, diffuse coagulation. Remember, DIC, diffuse, disseminated intravascular
What will that
coagulation.
do to the blood? Will it like
What will it do to the blood? What do you mean?
when
It
it's
will.
transfused and a whole bunch of blood?
Yeah, that's
Transfusion
why
reaction?
they do it very slowly, right? It's called
Oh, it's
transfusion
bad.
reaction. Drop by drop by drop. Even if it's properly matched, they still drop by drop. Because these are just the major antigens. There are actually, some books say there are up to 25 antigens right here on each cell membrane. These are just the major ones that cause a reaction. Yes?
Isn't there a type O positive also?
Mm-hmm.
Yes. Of course. Very good questions. You have any questions? So, then 5 minutes break and then we're going to do our lab. Okay?
Yeah,